Hello, so this is the second problem related to the Venturi meter. So let's start. A Venturi meter of 150 mm cross 75 mm size is used to measure the flow rate of oil. So previously we have used the water, but yeah, here it is the fluid is oil, okay, and the specific gravity of the oil is 0.9. That means the value of SO, that is 0.9, okay, is the specific gravity of the oil. Now the reading shown by the YouTube manometer connected to the Venturi meter. Okay, let's draw the Venturi meter first. So this is the Venturi meter and YouTube manometer is connected. So this is the inlet section, that means this is the section at inlet. So this is the inlet section, so this is the section at inlet. So yeah, here the manometer is fixed. And the pressure head difference, this is the pressure head difference, and the value, that is H, it is given here. The pressure head difference is 150 mm of mercury column. So this is 150 mm of Hg, okay. So here the value of SI, that is specific gravity of the mercury over here, that is 13.6, okay. So here it is section 1 and here it is consider the section 2. So here the diameter is given or not. So in this problem you can see, in the previous problem the diameter is clearly mentioned, but yeah, here in this problem it is also mentioned, just you need to see where it is given. Look, the size of the Venturi meter is mentioned over here, right? So what is this? Look, the size of the Venturi meter is generally specified in terms of inlet and throat diameters. So that means it is the diameter at inlet, that means it is the value of D1, and it is the diameter at the throat, that means it is the value of D2, okay. So we can write that D1 equals to 150 mm and D2 equals to 75 mm, okay. So now we can determine the area 1 as well as the area 2, that means the cross sectional area at section 1 and cross sectional area at section 2. So area 1, that means if you convert it in meter, so it will be pi by 4 into 0.150 square, and A2 will be same pi by 4 into 0.075 whole square, and the value of A1 is 0.0177 meter square. Please cross check. And A2 is 0.00442, 0.00442 meters square. So the A1 and A2 we already got. What is the final expression to determine the discharge? Here what thing we need to determine? Here we need to determine the coefficient of discharge. That means that discharge would be given. Look, yes, the flow rate is 1.7 meter cube per minute. So the flow rate, that means it is actually the actual discharge. So Q actual is given, that is 1.7 meter cube per minute. So 1 Q, so I need to convert it into meter cube per second. So just divided it by 60 and it will be 0.0283 meter cube per second. So this is the value of Q actual. Okay. Now let's determine the value of H in terms of H2O. Sorry. Now let's determine the value of the H in terms of the oil. Okay, because here it is given in terms of Hg, that means mercury. So what will be the value of H with respect to the oil? H will be the value which is 150 given here, that means with respect to the Hg. So converted into the meter, 0.150 into SH by SO minus 1. So SH is 13.6 by 0.9 minus 1. Okay. So H will be the value whatever you get, that will be in terms of the oil. Okay, that the fluid that is given in the question. So we will determine directly by putting in the formula. So we write the formula, that is to determine the actual discharge. So Q actual equals to Q theoretical into coefficient of discharge, right? So we need to determine the value of coefficient of discharge. So we can write in place of Q theoretical, that is A1 into A2 by root over of A1 square minus A2 square into root over of 2GH. Okay. So all the value you already know. A1 that we got, that is 0.0177. A2 is also known, that means this particular value, this is in meter square. Here A1 and A2 same value. Now G, it is 9.81. Here it is meter square, here it is meter per second square, and H value, that means this particular one. So you need to put the value whatever you get over here, and the final and that should be multiplied with the CD. Okay. So what will be the value of the CD then? Look, this total portion is the value of Q theoretical. Okay, and the value of Q actual is 0.0283. So here you put 0.0283. Now when you solve this equation, because in this equation you know all the value except CD, so you just solve this and you will get the value of CD, that is 0.963. Okay. So this is the ultimate value, and that we need to determine. Okay. So this is the second problem related to the orifice. Okay. So let's start. So water is discharged through a 15 centimeter diameter orifice. So here the likewise in the previous problem, here the diameter is 15 centimeter. In the vertical side, okay, so this is present in the vertical side of the tank. So vertical side of an open tank at the rate of 190 liters per second. So this is the value of Q actual. So the value of Q actual is given, that is given in liters per second. So 190 liters per second. The water stands 15 meter above the center line of the orifice. That means it is the value of the head. So the head value is 15 meter. A point on the jet measured from the vena contractor has coordinates 5 meter horizontal and 0.5 meter vertical. So consider this one is the vertical portion, and suppose there is some points, that means the orifice is there. and here it is said that a point on the jet, so consider the jet, the shape of the jet is something like this. So suppose this is that particular point, okay. So this particular point has the coordinates of which is 5 meter horizontal from the vena contracta, that means this particular point. So the horizontal distance of this point is 5 meter, and the vertical distance, that means if you consider this is the vertical distance, a second, yes, so this is the vertical distance and it is 0.5 meter, okay. We will determine all the values over here. So what we need to determine is find the hydraulic coefficients, that means CV, that means the coefficient of the velocity, CC, that means coefficient of contraction, and CD, that means it is the coefficient of discharge. So these values we need to determine, right. So the given data, these are the data which are provided, right. So we know that Q actual by Q theoretical is equals to CD, right. So from this relation we can write that Q actual is equals to Q theoretical into CD, and likewise we have done in the previous case, that means in the previous problem we can write over here in place of Q theoretical, it is nothing but area into the theoretical velocity, right, and this particular area is nothing but pi by 4 into d square, and d is here, that means the diameter of the orifice is 15 centimeter. So we just put the value over here, so area becomes pi by 4 into 15 is in centimeter, so we will convert it into meter, so 15 by 100 meter square, that means yeah, pi by 4 d square, and into the theoretical velocity, that means root over of 2g h into CD. So we can directly put the value over here, so g is equals to 9.81 and h is the value head, so head is given here 15 meter, so 15 meter. So we can put all the values, and also the Q actual value is also given, that is 190 liters per second. So you can convert this value into meter cube per second, and that will be 190 into 10 to the power minus 3 meter cube per second, okay. So I just put the value over here, means 190 into 10 to the power minus 3. So if you solve this equation, the value you get, that means the ultimate value is for CD, and the value will be 0.627, 0.627. So this is the value of coefficient of discharge, okay, that we have determined, that is 0.627. Now I am just removing this part. Okay, now look, this particular point, the coordinate of this point is given, that means it is horizontally 5 meter and the vertical distance is 0.5 meter from the vena contracta. So we can consider, that means let the jet travel during time t horizontally through a distance x, and the jet fall by the distance y during this time. So what I am considering is, let the jet travel during time t. Okay. Horizontally through a distance x, and the jet fall by distance, that means here you can see the fall over here, that is 0.5 meter. So here we consider the jet fall by distance y during this time. During time t, rather you can say. So that means I am considering a point over here. Consider, suppose there is a point. Now in time t, the horizontal distance of this particular point is x, and the vertical distance at this point is, that means this particular distance is y at time t. Okay. So from the physics we already know the horizontal distance it covers, that means the value of x equals to Vt. Okay, where V is the flow velocity. So x equals to Vt. So what we know, the flow velocity equals to Cv into root over of 2gh, right? Root over of 2gh, it is actually the theoretical velocity, and this is the flow velocity, rather you can say actual velocity. Okay. So in place of capital V, we can write that Cv into root over of 2gh into t. So you can make it a square, and we will get something like this: x square Cv square 2gh into t square, something like this, right? So give it equation number 1. Now you know this formula, you are familiar with this, I hope, that v square is equals to u square plus 2fs, s is equals to ut plus half ft square, also v is equals to u plus ft. So these are the formula we already learned in 10th or 12th standard, right? So here we will consider this particular one, that means s is equal to ut plus half ft square. So this is the distance covered. Now u, in our case it is 0. Okay. So in our case we will consider only this particular portion. Okay. So here the s will be converted into the y, that means this particular distance y. So y is equals to half ft square, not f, because here the acceleration, that means it is g. Okay, that means acceleration due to gravity. So here our formula will be y is equals to half gt square. Okay, so we will write over here, that is y is equals to half gt square. Okay, so g is the acceleration due to gravity, and you just give it the equation number 2. Okay, now if you divide equation number 1 by equation number 2, that means 1 by 2, what you will get, that is x square by y equals to 4 Cv square h. Okay, so this particular thing, this is the equation that you will get. So I just removing this part. So now what I need, we need to determine the value of Cv, right? So Cv equals to root over of x square by 4yx, sorry 4yh. Okay. So, this is the final expression that we will need to determine the value of CV. Okay. So, yeah, the derivation is very much important to determine the value of CV. So, we can directly put the value over here. So, we know the value of x, we know the value of y as well as the h, right. The value of x is 5 meter, the value of h is 15 meter, right, it is 15 meter, and the value of y is 0.5 meter. Now, simple, very simple. So, what will be the value of CV? The value of CV, you just solve it and you will get the value of CV, that is 0.913, 0.913. Okay. Now, you know, now we got the value of CV as well as the coefficient of discharge. So, we just need to determine the value of CC, that means coefficient of contraction. So, it is nothing but the ratio of coefficient of discharge by coefficient of velocity. So, you know the value of coefficient of discharge that we got. I just remove this. The value of CD is 0.627 and CV just we got 0.913. So, ultimately the result, just check it, 0.627 by 0.913. So, it is 0.686. 0.686. So, yeah, this is the solution, very simple. So, try to solve this kind of problem. Thank you.